Okay, hello everyone. I hope you hear me well. Good. So this is the second live session that we have. In this session, we'll be looking at complex numbers. I hope you all watch the videos. So and in case you have questions related to them, you can simply use the chat to ask your questions on these topics. So just as a warm up, let's go to item pool. So let's start with a problem right away, if that's okay. So what I want you to do is to go to itempool.com/math1055/live and answer the question that appears there. So just to read it, you might not be able to see it. It's a bit small. So it's asking you what is z squared if z is equal to 1 plus I. Okay, so I can already see people answering it. Very good. So feel free to just take out a pen and paper and calculate the square of this complex number. So this is just the first thing. I'll give you a few minutes just to okay. Yes, I see the majority of answers is for one option. Yeah, basically almost everyone has voted for one particular answer, which I don't know like which option did you choose. There is an option. So if you think you got it wrong and you would like to change your answer, you can do that. So there should be a button or a place on this item pool website where you can click on change my answer or change answer, and then you can input or choose another option. Okay. Okay, so something like 109 people have voted. There's 140 of you. So there's still some time if you want to grab a pen and paper and calculate the square of this number. Choose. So the options are, let me just read them. The first option is I, the imaginary unit. The second option is 2i. The third option is 2, is the number 2, and the last option is -1. Okay, I'm happy. This is an indication like having this many people, 111 of you voting for the same thing is a good confirmation that you have learned at least basics of complex numbers. Good. I think I'll just reveal the answer since almost everyone has voted. Let's see. So it was 2i, and yes, basically everyone was right. Good. And so I guess I don't have to, but let me just quickly go through the calculations. So I will use this view to show you stuff if something needs working out. So what we had is the number 1 plus I squared, right? So if I take that just means multiplying 1 plus I by itself, Okay, if I expand that product, I will get 1 squared, I will get 1i, I will get another I, and then I will get I squared for my last term. And this is where you use that I squared is equal to -1. So the ones cancel, and you get 2i for your answer. Okay, that's it. I mean, it was a simple calculation. You probably could do it in your head. So this is something that hopefully was okay for everyone. Now let's go to the next one, maybe, unless you have questions. So I will try to look through your questions. Yes, there's a discussion on the homework. How much is that contributing to the final grade? It's 15%. So someone has already answered that. Good. So it's really the exam that is, the most important thing for passing this module. But if you think you can learn everything, during your revisions, you are wrong. So it's always better there will be 5 homework sheets. So it will be always better to go and prepare each week. Because I mean, there is just too much stuff, and you have other modules as well. So okay, so at the moment I don't see any other questions that are kind of important. And it would be, I mean, I understand that you want to pass this module. That's great, that's good, but please don't be obsessed with marks and points and whatever. I mean, that's, of course, it's important. I mean, that shouldn't be the main goal here. Now, okay, since there are no other questions, let me go to the next one, the next problem. So here you see 2 complex numbers, and I have this little drawing. So we have the complex plane. The question is, what is the sum of the complex numbers 3 plus 2i and -4 plus i? Okay, so what is the sum of these 2 numbers? You have to add these 2 numbers, and there's just this picture sort of next to the problem, or below the problem, that would help you visualize this whole thing. Let's see. Again, I see a good number of people voting for inputting the same thing. That's already good. So it's a little box that you have there on the side appearing. That's what you have to use. If you click or tap on this box, like a virtual keyboard should come up, and you should be able to put in your answers that way, or maybe even you can do it even without that keyboard. Okay, again, a really big majority is inputting the same thing. This is good. Again, adding complex numbers is not the most complicated thing that you will do, but it's good to have the basics at least covered. And I can see that you all know this stuff really, really well. Let me reveal the answer here. So I close the poll. Yes, so it's -1 plus 3i. Again, let me just quickly show you. I mean, how it can be seen. So there's the problem, the same two numbers, the same sort of diagram. And yeah, to add complex numbers, let me just zoom in a bit. So to add complex numbers, what you would do is just simply add these vectors as you would know already. So let me just put these numbers there, the arrows pointing to the numbers. So we have 3 plus 2i, and we have -4 plus I as the two numbers. And what you can do is you can basically slide one vector along another vector, and this way what you will end up with is this shape where the red vector, so this one, will point to the point that represents the sum of these two numbers. You can do the same thing with the other vector as well, and what you will end up with is this nice parallelogram rule giving you the sum of these two numbers. So that would be pointing to that place. So that's the number -1 plus 3i. Okay. So that was well, it wasn't too bad, I guess. That was the second problem. I don't see any questions related to these. So we can go, I guess we can go to the next one. Hopefully we'll get through all problems I prepared. So far we are doing well. So let me just tell you basically what you all did, I guess. Let me go back quickly to this previous view. What you all did, I hope, is just took these numbers and added the real parts. That way you got -1, and then added the imaginary parts. That way you got +3. So that's why the sum is 1 plus 3i. Okay. So that's addition. We had multiplication in the previous one. Now let's move on to the next one. Let's see. So this is going to be a bit more complicated. I hope we'll reach a point where actually be challenging. So the task is to bring the complex number z, which is the ratio of 1 plus I and 1 minus I. So it's a fraction of 1 plus I divided by 1 minus I. And I would like you to bring this number to its algebraic form, which means to this usual form of z equals 1 plus I, 1 plus yi with that is not 1, sorry, x plus yi, where x and y are real numbers. Okay, and you can again use the box to input the answer. So again, what I would like you to do is basically do division, compute the ratio of these two numbers. I'll give you a few minutes for all of you to go through the calculation. There is a very standard method. I hope you have all seen that in the video, or you know it already. There is a very easy and basically algorithmic way of computing the ratio of two complex numbers. Okay, so far again can see kind of a big bar above my head. That's 50 something people inputting the same answer. Then there are a few, like well, the other way. We have a few mixed answers. So it cannot be more than one thing. So it's a unique number. So in case you think you made a mistake in your calculations, you can change your answer. You can look at the question and click change answer, I think, and then you will be able to input a new answer. Okay, I'm looking at the questions. Okay, I don't see any questions, but feel free to ask your questions. Again, it's a good number of people inputting the same thing, which is good. Yes, so this, well, I mean, one has to set it up so this website recognizes equivalent expressions. So I hope you didn't cheat. I mean, it might actually be clever enough to calculate the ratio itself. So input 1 plus I divided by 1 minus I, it might actually give you, full mark for that. But yeah, what I'm hoping is that you actually done the work and put your answer in that box. Okay. All right, so there is a good number of people who have voted, but there is, I think, something like 30 to 40 people who are not using the website, this itempool.com. Let me see if I can put it in the chat again. So feel free to go to this website and you can participate, you can interact with me in that way. I'll give you these questions, you can answer them. But hopefully this problem had enough time. You had enough time to think about this problem. Let me reveal the answer. Yes, there it is. So it's I, and I see that there are some equivalent answers. So if you look here on the side, you can see answers like 0 plus I. So these 7 of you took it literally. You wanted to input it like x plus yi, and x turned out to be 0, y turned out to be 1. So you have inputted 0 plus I, which is good. I mean, it's correct answer. If I would see that in a test or in your homework, I would be happy with that. Similarly, we have one person there with 0 plus 1i. That's also good. So, but the real part, since it's ZS, it can be omitted. So I was happy with I was happy with 0 plus I, and 0 plus 1i is also good. 1 times I, you can see 2 over 2i. They are all accepted by the system, which is good. Okay, so let me just for everyone, because I see some wrong answers, which is okay. I mean, at this point we can make mistakes. It's no problem. Let me. This is what this session is for, to learn from our mistakes. So let me just quickly go through the calculation. Is real simple. So you have 1 plus I divided by 1 minus I, right? And the big trick that you can always employ is to take the denominator and multiply the whole fraction by a funny looking 1, actually. So what you do is you take the denominator and you put the complex conjugate of the denominator in another fraction where it's divided by itself. The complex conjugate of the denominator is divided by itself. It is just 1 written in a funny way, but there is a good reason for us to write it like that. And the reason being is that when you simply multiply the denominators, you will get a real number, and that by that you can divide. So first we have the product of the numerators. So that's 1 plus I squared, that's minus 1. You see, this is the first example we had. Then we have I plus I, so that was 2I. And in the product of the denominators is going to give you 1, then minus I squared. So that's giving you plus 1, minus I squared. And then you will have the cross terms plus I and minus I. So these are they are going to cancel each other, and you will be left with 2 in the denominator, giving you I as the final answer. Okay. So and this number can of course be written as 0 plus 1I. Right. I hope that was clear. So that's division. Okay. I don't see any questions at them, so let me just go to the next one then. Okay, so this one, oops, I did. Okay, so I messed up. Yes, let me go back. Let's just do it, but because even though I revealed the answer, yeah, it's a slow. I will have to be careful not to click twice if I don't see things happen immediately. So anyways, now you know the answer, but it's okay. Yeah, and if you missed it, it's even better. Now, so this problem is about the polar form of complex numbers. So the question is, which point does the complex number z equals 3 times the cosine of minus pi over 3 plus, yeah, there is a typo. I just discovered the typo. There should be an I in front of the sine of minus pi over 3. Okay, so this is a complex number, not a real number. There should be an I up there in front of the sine of pi over 3. And you can choose from 4 points. Okay, let me just scroll down a bit. No, I can't scroll down, but you can probably see it on your screens if you open this website. Let me see if I can actually scroll down. It will take a... Yes, so there it is. Okay, so you have 4 points here on the complex plane. You have this point A up here, then B down there, C in the second quadrant, and then D down along the imaginary axis. Okay, so these are your options, and I see you have voted already. So in order to see where a complex number is, you are given the polar form, which is, again, there is a typo. There should be an I, an imaginary unit multiplying the sign, of negative pi over 3. So if you are given a complex number in its polar form, such as this one, you can tell that it has a length that is 3. So that's the 3 multiplying the whole thing in a bracket. And that will tell you that the complex number is 3 units of distance away from the origin. Now, the other thing that is needed for the polar form of a complex number is the argument, or the angle of the complex number. Okay, there are already some answers revealed. I can see 6 people voted for C, and they are already revealed somehow. And there are 2 people who voted for for A. You can change your answers. Yeah, you are not in the majority, at least. I mean, you could be right, but at this point we don't know. Well, most of you know, but because I messed up and revealed the answers. So there's a good question about the argument of complex numbers. So in this module, we'll have the sort of the rule or the convention. You know, it's just something that we have to agree on, how to measure this angle. And I asked you to use radians because everything is nicer in radians, and that's a natural way to measure angles, if you wouldn't know. And we go from negative pi, minus pi to plus pi with the radians. If you are used to this, we are going from minus 180 degrees to plus 180 degrees, instead of going from 0 to 360. Okay, so from 0 to 2 pi would be an option, but we choose to stick to this interval of negative pi to pi. Okay, I'm not sure about this question. How would we work it out if 2/3 of the possible points were 3 away? I'm not sure about this question, what it actually asks. Yes, there's a good hint. You have to think about the quadrants, indeed. Okay, so I see lots of people have voted. Let me just reveal the answers again. Reveal the answer, and I see, yes, most of you got right again, which is good. So this one was a bit more, well, there were a few incorrect answers. So let me fix, let me just tell you, oops, that's a bit too bright. So let me just tell you how it goes. I believe I have it somewhere. Yes. Okay, so here it is, the same diagram with the 4 points, and our number, if I'm not mistaken, was 3 times the cosine of negative pi over 3 plus, and there was a typo, an I was missing from in front of the sign, my I times sine of negative pi over 3. Okay, so that was the number that we were looking for. Again, the first factor, 3, is the modulus, or the length of the complex number. It tells you how far away it is from the origin. But all of these numbers, if you can see it, I don't know if let me try to zoom in. So there is this grid, and this is 1 unit from on the real axis. That is 2 units of this, 2 units of distance, 3 units of distance. So that is a square circle of radius 3, meaning that all of these numbers are having the same modulus, that is 3. Okay, so it's the argument that will decide which of these 4 numbers is represented by Z. I think I had it named Z. And for that, you have to look at arguments. So it's negative pi over 3, that's minus 60 degrees. If you can, you know, pi radians is 180 degrees. So minus pi over 3 is negative 60 degrees. And you just have to remember how to measure the angle. So the way we measure these these angles is we take the positive real axis and the vector connecting the origin with our point representing the complex number. Okay, so if you want to measure out negative 60 degrees, that means we go down 60 degrees in that direction. So that's minus pi over 3 radians. That gives us the argument. So it will be this number in. So the correct. So this is Z, and that B point B was the correct answer. Okay. I hope it was kind of clear. You could also do it basically without using much of this diagram, without using this angle interpretation. You could have just plugged in, well, just calculated the exact values of the cosine of minus pi over 3 or the sine of minus over 3. Okay, and the point is that basically this number will have a negative imaginary part, because the sine of pi over 3, the sine of pi over 3 is positive, is root 3 over 2, if you remember. And we have this negative, this minus sign here. So it's minus root 3 over 2. Let me actually turn that into an algebraic form. So we'll have 3 times minus root 3 over 2 times I, and for the real part we have the cosine of minus 60 degrees. That's actually 1/2. Okay, so you might remember these special values of the trigonometric functions, and this is basically our complex number. Of course, one can write it as by expanding this product as 3/2 plus I minus I times 3 times root 3 over 2. Okay, and it basically tells you that the real part of this number is minus is plus 1/2, so that's 3/2, and that is minus 3 root 3 over 2. Okay, so I hope this was clear. Let me go back to these problems, and if there are no questions, yes, we can move on to the next one. So the next problem is asking you, so I'll begin accepting the answers. So let me just read the problem statement. So it is asking you to rotate the number Z equals 3 plus 2I by 90 degrees counterclockwise about the origin. And drawing of complex plane with 3 plus 2I, and I'm asking you to rotate this vector around the origin, about the origin, by 90 degrees in the counterclockwise direction. And the question is, which number will you get? And there are 4 options. The first option is 3 plus 2I. The second option is negative 3 plus 2I. The third option is negative 2 plus 3I. And the last option is 2 minus 3I. Okay, so what question did I ignore? Could someone? Oh, if a complex number is in polar form, is there a way to find the complex conjugate without reverting it back to into algebraic form? Yes, it's just still flipping the sign of the imaginary part, which means a sign change for the angle. And since the cosine function is even, that won't affect the real part, which is as it should be, and the sine function is odd, so it will change its sign into, well, flip its sign basically into the opposite sign, which corresponds to flipping this vector upside down. Well, you know, reflecting it through the real axis. Okay, I see these. So now it's very interesting. The answers, there are two. Yeah, okay. There is one clear winner at the moment. There are 60 people who have voted for one particular answer, but there is 38 of you who have voted for something else. Oh, what I mean is, yes, you have to the sign, yes. Well, you can do both. I mean, if you change the sign in front of the sine function, that term, that is the same thing as changing the angle to minus that angle. Okay, that's what I'm been explaining with these with these functions being, the cosine being even, and the sine being odd. Okay, so there's already more than 100 of you have voted. So let me see if I have something for this problem. Yes, I do. So I will finish and reveal the answer in a moment. But you can still go to this website and try and choose your answer. Okay. Yeah, there's been some few extra votes. I hope you're all satisfied with the time given to this. Let me finish and reveal the answer. So it was C, -2 plus 3i. Okay, so let me try to show you why that's the correct answer. So here is my drawing. It's the same figure having the complex plane with this number 3 plus 2i represented by that vector. And well, I can again use my very high-tech solution here. I have this vector, and what I asked you to do is to rotate this vector by 90 degrees in the counterclockwise direction. So something like this is what I asked for. And I don't know if you can see, probably you can't see this very well, but there are those grids. And if you look at these grid lines, you will see that that's 90 degrees more or less. And you can see that the real part of this number is -2, and the imaginary part of this number is +3. Okay, so that number there is -2 plus 3i. Okay, and that was the solution, -2 plus 3i. So let me go back here. Here I have the vector I get by rotating my previous one, my other number. So, and there is something here I would like to actually show you. So this rotation of a number, of a complex number, or the vector representing it by 90 degrees, can be written, can be thought of as multiplying by a complex number. So look at the following. If I take this number, 3 plus 2i, and multiply it by I, what will I get? Well, multiplying 2i by I will give me 2i squared. So I squared is -1, so that gives me -2. And multiplying 3 by I, that's just 3i. And indeed, what I got for an answer is this rotated vector. Well, the number corresponding to this rotated vector. Okay? So there is this comment on how to rotate and get a point from the coordinates of the point. But if you have it with coordinates x and y, you can get the coordinates of the point that is rotated around the origin in the counterclockwise direction by 90 degrees, and that is how you get it. You flip the two coordinates and change the sign of the first coordinate. So that's exactly what's going on here. If you know about matrices and matrices of rotations, about the origin, you might be able to connect these things. So in short, multiplying by I leads to a 90-degree rotation in the counterclockwise direction. And this is true in general. So it's not just this special number 3 plus 2i which gets rotated. Actually, if you take, and again, I'll do some magic here. So I hope you are prepared for your minds to be blown. So there is the complex plane with the little vector, the red one. If I multiply every number by I, the imaginary unit, what will happen is this complex plane, all numbers get rotated by 90 degrees. So something like this. You can see how the red vector overlaps with the green one. Okay? So this is what happens. So rotating by I takes you from here to here, all the way to here. Okay? So, I mean, I know this is crazy. I mean, when I came up with this idea, I was so proud. I know. But all of this is just to show you, how what multiplication by a complex number does to the other complex number that is multiplied. Okay, let's go to the next one. The next problem. I believe this is the last one. So this is a tricky one, and indeed it might be a bit too difficult. I hope it's not. If you watched all the videos, you should be able to answer this question, which asks you to decide which quadrant does the complex number z to the 10th power belong if z is equal to √3/2 plus I/2. Okay, and just to show you, I mean, these are the four quadrants of our complex plane. So for the first quadrant, we have positive real and imaginary parts. For the second quadrant, we have negative real but positive imaginary parts. The third quadrant, both the real and imaginary parts are negative. And the fourth quadrant, we have positive real parts and negative imaginary parts. Okay, so let me go back. Now you know which quadrant is which. And what I'm asking you to do is figure out which quadrant will this number end up in when you raise it to the 10th power. Okay. Oh, sorry. I have to begin accepting answers. Yes, sorry about that. At least you all know what the problem is, and then the race is on. So the number that is given is √3/2 plus I/2. Okay, so I can tell you, like, give you a hint. This is de Moivre's theorem that is applied here, or that can be applied here. You have a number, you raise it to some integer power, and that does, well, of course, something to the number. But the question is where it's going to end up. What is the angle really that I'm asking, right? Because not precisely the angle, but more or less which quadrant does it end up in? That depends on the angle. So if you have an angle between 0 and pi over 2, so 0 and 90 degrees, you would be in the first quadrant. If you have an angle between pi over 2 and pi, you are in the second quadrant. If the argument of the complex number z to the power 10 is between minus pi over 2 and 0, then it means you are in the fourth quadrant. And for angles between minus pi and minus pi over 2, you end up in the third quadrant. Okay, so take your time to take this number z, write it in its polar form. So that is what de Moivre's theorem is working with. Yes, a calculator is helpful, but you don't actually have to have a calculator. And yeah, I mean, you can of course always cheat and put it in to Wolfram alpha or something, but the idea here is you can easily calculate something like this, or without using calculators. So if you know these special values for the trigonometric functions, which is like √3 over 2 or half, then you will be able to know that's nothing like binary expansion. It's not the exponent is not in binary. It's in base 10. Okay, so there are lots of votes, but they are still coming in, which is good. It means all of you are working hard. Well, not the people who have voted already, but okay. So I will reveal the answer in a minute, and then we can just finish this session. Is a calculator allowed to solve this question? I mean, that just defeats the purpose in the exam. I think, how is it? That's actually a good point. So be prepared that the exam, since it will be an open book exam, it will be challenging. I mean, of course, you should be able to solve it. I mean, based on the videos, the lecture notes, whatever we do during the term, we'll prepare you for the exam. But yeah, I won't be standing over your shoulder and telling you not to use a calculator. So since it's an open book exam, you will be able to use whatever you want. And that is why it's going to be a bit more challenging than a usual book exam. Okay. So there are a good number of answers, almost 100 votes. Yes, the past papers. I think it's not on Minerva yet, or it might be accessible from Minerva. When you go to your list of modules, I think it should say next to each module, there should be an icon saying past exam papers. Okay, so we have a good number of answers. Let me reveal, or votes. Let me reveal the answer, and then quickly tell you why that's the correct answer. It's the fourth quadrant. Most of you got it right, which and you all did really well with these problems. So I'm happy that you got the basics right and covered when it comes to complex numbers. This is good. So let me show you this other view. Where is it? So this one, yes. So here is the number, √3/2 plus I/2. This was the number that we had to consider. You can rewrite this number as the cosine of pi/6 plus I times the sine of pi/6. Okay, so basically what you have to realize is that this angle is pi/6. It's 30 degrees, and the length of this number is 1. So it's sitting on a unit circle. Okay, it's not a perfect circle, but that's the point. The angle is pi/6, and when you raise it to the 10th power, what you are going to end up doing is, so this is z. What you are doing is you are taking multiples, the 10, multiplying the angle by 10. So when you take a complex number and raise it to the 10th power, you will do the following to this number. It's going to pick up its own angle 10 times. So that's z to the 4, z to the 5th, 6th power, 7th, 8th, z to the 9, and there's our number that we were looking for, z to the power 10. Okay, and it ended up in the 4th quadrant, and basically, again, this was pi/6 radians, or 30 degrees. If you raise z to the 10th power, that means multiplying the angle by 10. So the argument gets multiplied by the exponent, and 10 times 30 degrees is 300 degrees, or minus 60 degrees, or minus pi/3 radians. So this way, by applying the Moivre's theorem, you could easily figure out which quadrant does this number end up in. Okay, so I hope you enjoyed solving these questions. So let me end the session, and I thank you all for coming. I hope to see you next Friday. Do feel free to ask me questions, just like you did so far. You've been all really great. Thank you for attending, and take care, you all.